Let's start and program the Altera board. To program the Altera board, you need to connect the USB blaster, the power supply, and connect the wire provided with the Altera board to the GPIO. In this board we soldered these pins to the UART section in order to use the UART without an external connector, and we can use the ground of the UART as a switch connecting the wire to ground. So turn on the board. When you turn on the board, you can see the default design loaded in the board, and then start Quartus Programmer. And start programming. When the Quartus finished programming, you can see our design loaded. So we have the 7-segment LED to 0. This is the reset. You can see the LED blinking when I push the button, and then pushing the button 2, you can see the counter that counts +1 and LED that turn on every time I push the button. Now let's try with the external switch. As you can see, when I touch the ground, the counter counts more than +1 because there is a bouncing, as you can see on the LED blinking, that provide more than one pulse. So we need a circuit capable to debounce the switch. If I push the button, the reset button, I reset the counter. So it's time to start coding. Open Lab 1 folder that contains 3 files in VHDL folder. Counter_up4, that is the up counter, rising edge detector.vhd, the edge detector, and DA0 FPGA, that is the top level of the FPGA. In the TB folder contains the simulation script. So you need to open the VHDL file and complete the code where you find insert your code here. Set the simulation folder as lab1/VHDL and create the library work. Then simulate the code in order to obtain the behavior that you saw in the live section, and lay out the VHDL code in order to lay out your VHDL design as explained in the live section. If you need help, Lab 2 contains the solution.